right, the topic today is called the quadratic formula. The essential question, or our target, is how do you solve a quadratic equation using the quadratic formula? The quadratic formula. Example 1. We are going to solve 2x squared minus x equals 4 using the quadratic formula. Alright, so the first thing we want to do, kind of like when we factor and we have to get it set equal to 0 in standard form, if it's not already, that's how you'll start this off. So obviously it's not set equal to 0, so we will subtract 4 from both sides. And we get 2x squared minus x minus 4 equals 0. Then, just like when we factor, we are going to identify what A, B, and C are, okay? So we know that A is equal to 2, B is equal to -1, and C is equal to -4. And we're going to take those numbers and substitute them into the quadratic formula. So you know how I've taught you so far 2 ways to solve a quadratic equation. One way is to factor. T-chart, divide and slide, set each factor equal to 0, right? We learned that method. But factoring does not always work. It does not always solve a quadratic because not everything's factorable. I also taught you how to solve a quadratic equation by completing the square. That was like the last lesson we learned before our test, okay? Completing the square method always works to solve a quadratic. This is another way that you can solve a quadratic equation. Quadratic formula. It always works. So the only one that doesn't always work that we've learned so far is factoring, okay? So before we can substitute these values into the quadratic formula, we have to know what the quadratic formula is. Some of you already know. X equals -b plus or minus square root b squared minus 4ac all over 2a. Yeah. Y'all know that song? No? You don't like it? Thank you. So when you go to college and they don't give you the formulas for the test, you'll remember this one because by the time I'm finished, you'll know this song too. And it will get stuck in your head. So notice there's A's and B's and C's in here in some numbers. So wherever I see an A, I'll substitute in a 2. Wherever I see a B, I'll substitute -1. and wherever I see c, I will substitute -4. And I'm trying to solve for x. So x equals, I have -b, so I have a negative here, and b is also a negative, so I'm going to end up with a double negative. Plus or minus the square root of b squared, so that's -1, and I'm going to put it in parentheses to make sure that I square the negative as well as the 1. Then the formula says to subtract 4 times a, which is 2, times c, which is -4. And put that whole thing over 2a, which in this case would be 2 times 2. And then we just simplify that using the order of operations. Okay? Anybody have a question so far? Alright, so we have x equals, what happens when I subtract a negative? It becomes a positive, right? So +1 plus or minus the square root. I gotta do some simplifying under here. So always do b squared first, which -1 quantity squared is +1. And then I do -4ac all together. Okay? So it's -4 times +2, -8 times -4, +32. So that minus sign ends up becoming a plus sign. So I'm adding 32. Okay? And putting that whole thing over 4. So that gives me x equals 1 plus or minus the square root of, that becomes 33, all over 4. Now, if that was like 1 plus or minus the number 3, then I would need to simplify that further, okay? So you might see your answer written like this, or they might write it as 2 answers, which would be 1 plus the square root of 33 all over 4, and 1 minus the square root of 33 all over 4. Or say I was using a quadratic formula to graph my parabola, and you know that your solutions tell you where the graph crosses the x-axis, right? So if I'm going to graph this parabola and I want to figure out where it crosses the x-axis, where am I going to find 1 plus the square root of 33 quantity divided by 4 on my x-axis? I'm probably not going to find that, right? So if I wanted to turn that into a decimal, I could figure out what the square root of 33 is in my calculator, and I'll tell you it's approximately 5.7. Now when you turn it into a decimal, then you're going to be approximating. This is the exact answer, okay? But when I turn it into a decimal, I'm going to have to round. So that would be 1 plus, if I'm rounding to the tenths place, be 5.7 quantity divided by 4, which gives me 6.7 divided by 4. So that's approximately 1.4. That's an approximation. And then if I subtract the square root of 33, that's approximately subtracting 5.7, which 1 minus 5.7 is negative 4.7. Divide that by 4, and x is approximately negative 1.175. On your test, if it's multiple choice, it'll either look like this or this, okay? I will not have decimals as their multiple choice. But say you were graphing, you would want to know how to put it as a decimal. Or say you were taking the ACT or the SAT, and they may have their answer in decimal form. Coolio? And that's it. So if I would have solved this by completing the square, I'd have gotten the same answer. If this was factorable, which I'd have to work it out to see if it was factorable, I would have gotten the same answer. So I'm going to do 2 more with you. So this tells me that if I were to graph this, my parabola would cross the x-axis at 1.4 approximately and negative 1.175 approximately. Y'all ready for example 2? Let's do it. X squared plus 4x equals negative 4. First thing I do is what? Get it set equal to 0 in standard form. So I'm going to add 4 to both sides. So it's x squared plus 4x plus 4 equals 0. Then I'm going to define A, B, and C. What is A? 1. What's B? 4. And what's C? 4. And then I'm going to substitute those numbers into the quadratic formula. So we have to know what the quadratic formula is. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Yeah. Yeah. I like to throw that in there. Yeah. Alright, so that's x equals negative b. That means, I like to say opposite of b, so if b is positive 4, it's going to become a negative 4 plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 1, times c, which is 4, all over 2a. So in this case, that's 2 times 1. Am I going too fast? We okay? So outside that radical, there's nothing to simplify there. Just bring it down for now. X equals negative 4 plus or minus the square root of, what is 4 squared? 16. And then I do the minus 4ac all together, including the minus sign, okay? So negative 4 times 1 is negative 4. Negative 4 times positive 4 is negative 16. All over 2. So x equals negative 4 plus or minus the square root. 16 minus 16 is 0 all over 2. Can you take the square root of 0? Yeah. What is the square root of 0? So negative 4 plus or minus 0 all over 2. If I add 0 or subtract 0, is that going to change the minus 4? No. Negative 4 plus 0 is negative 4. Negative 4 minus 0 is negative 4. So really, that's just negative 4 divided by 2, which is just negative 2. So this one only has one solution. Technically it's two solutions, but they repeat themselves. So that means if I were to graph this, my vertex would be right on the x-axis since it only intersects at one time. So you're only going to get that one solution when what's under the radical, that's called the discriminant, by the way, when that all simplifies to 0, that's the only time that you'll just get one solution. Okay? If that's any other positive number, you're going to get two solutions. What do you think happens when the number under the radical is a negative number? What? You get no real solution, but you will get two imaginary solutions. Example 3. (2x squared minus 3x plus 7 equals 0. Now this one's already set equal to 0 in standard form, right? So we don't have to do that part. So we can just define A, B, and C. So what is A? Two. What is B? -3. And C is 7. And I will substitute those values into the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. Yeah. You're going to love it. Okay, so we have x equals the opposite of b. Well, b is -3. When I substitute that in, there's going to be another negative. What's it going to change to? +3. So you can just go ahead and do that now, or you can write minus -3 and simplify the next step. Either way, you're still going to get +3. Plus or minus the square root of b squared, that's a negative, so make sure you square the negative as well as the 3, minus 4 times a times c. So it'd be -4 times 2 times 7. All over 2a, so in this case that'd be 2 times 2. So we have x equals 3 plus or minus the square root of, what's -3 quantity square? +9. When you square b, it's always going to be positive. So if you find yourself putting a negative there, it's not. Negative squared's a positive. A positive squared's a positive. All right, minus 4ac. -4 times 2 is -8. -8 times +7 is -56. All over 4. You might have a question? Alright, so that's x equals 3 plus or minus the square root of 9 minus 56 is -47 all over 4. We have a negative under the radical. What does that tell us? We have imaginary solutions, right? Now, so sometimes your directions will say find all real solutions. If it says find all real solutions, there are no real solutions, okay, because that negative under the radical. But if it says find all solutions, that means it wants real and imaginary solutions, all right? So we would need to keep going. So we have x equals 3 plus or minus. What happens when we take the square root of a negative? What do we get? Remember the I outside of the radical? And is 47 a perfect square? No. Does it have any perfect square factors? No. So can I simplify 47 even further? No, not without turning into a decimal. And usually when you have imaginary numbers, they don't usually turn them into a decimal, not that I've seen. And that's all over 4. So you'll either see the answer written like that or as two separates. 3 plus I square root of 47 all over 4, or x equals 3 minus I square root of 47 all over 4. Now, if the solutions tell you where your graph crosses the x-axis, but you have imaginary solutions, where does your graph cross the x-axis? It doesn't, right? So when you have an imaginary solution, that means your graph's never going to cross the x-axis. I'm just going to make that little important note in my notes. Is everybody good with that?